We have seen the collection interface, the methods in collection interface. We have seen the list and the methods in list interface. Okay, now we have seen array list, the implementation class also of the list interface. Obviously, since list interface is a child interface of collection, so the collection methods and the list methods are all implemented inside the array list implementation class. The next we are going to see is linked list class. Okay, linked list is also an implementation class. Okay, its underlying data structure is doubly linked list. Its underlying data structure is nothing but doubly linked list. So we all know what is a doubly linked list. So what is a doubly linked list is? It's simply that we have a linked list, and from the front and from the back both we have our we have a linked list, and from the front and we are back we have our pointers. Okay, pointing to the next node and pointing to the previous node. From the next and the previous, the next and previous, next and previous. Okay, so this is a doubly linked list. So I know that we all know what is a doubly linked list is. Okay, so the underlying data structure is nothing but a doubly linked list. Insertion order is preserved, duplicates are allowed. This is also same because it is an implementation class of list, and list has these features. So obviously these features are also true for linked list class. Next is our constructors. So the constructors of linked list class is first is linked list to create an empty linked list, and the second is the collection one. So you used to create an ordered list which contains all the elements of a specified collection. If you want to pass a collection, you can pass a collection and it will create a linked list out of that collection. Okay, there are some methods which are specific to linked list class. Okay, these methods are not in the list interface or in the collection interface. That this add first. So we know these methods. If you want to add at the beginning, if you want to add at the end, if you want to get the first object, if you want to get the last object, if you want to remove the first object, if you want to remove the last object. So these methods are specific to linked list. Therefore, it is not provided in the list interface or the collection interface. If they were provided in those interfaces, then array list has to implement these methods. But these methods are just in linked list class. They're specific to linked list class. So now we will code and we will see the methods. Obviously, linked list class uses the list interface methods and collection methods also, because it is nothing but an implementation class of these interfaces only. Okay, so let's now code a linked list. Okay, so we have a class, linked list class. Fine, we will pass our parameter, that is a type parameter. So for example, I am passing character as my type parameter. Generics is used here. Let's create an reference variable, for example linked list object. Okay, now create an object, so new linked list. Fine, so we are using the first constructor in this case. Next is we will add some values. So ll object dot add. Now let's add a. Fine, ll object dot add and add b. Okay, now I will add few more values. So let's see. So I have added 3 more values in it. Fine, so let me print now s out, and I will simply call ll object. So when I print this, it will be simply a b c d e that is added to the linked list. So we do not have to write any push method by our own. So here, as you can see, a b c d e is added. Fine, so next what we will do, we will remove some elements. Okay, so ll object dot remove, and I will pass the index as 3. I will pass the index as 3. So now there is a confusion. Linked list does not have indexes. Arrays have indexes, but the linked list that we have learned till now does not have indexes. So how we can pass an index in linked list? So if we are using arrays, so 0, 1, 2, 3, the index is 3, and if it says that remove the object at index 3, and if I print it, so how it is deleting that element, that object at index of 3, because linked list does not have indexes, arrays have indexes. Okay, so a b c is deleted. So what is the difference between these, array list and linked list? If the linked list also have index, it can perform all the operations that our array is good at. So let's see what is happening. I have a linked list. Fine, so also I have a doubly linked list, not just a linked list, I have a doubly linked list. Okay, because the underlying data structure of a linked list class in collection is doubly linked list. Fine, so also obviously I will have a head pointing to 100, so it will be 200. For example, it is 300, and it is 1, it is 2, it is 3. Okay, the next is 200, the next is 300. Here it is null, the previous was 200, the previous was 100, and here it is null. So a simple linked list. Now if I get that my index dot remove 2, remove the element at index 2, so 0, 1 and 2, So 2 is here, 0 is here, 1 is here, but these indexes are not available for linked list. These are indexes are available for arrays. So how do you think this function works? So obviously, how will it work? If you are going to implement it by yourself, how will you implement this function? You will traverse the list. You will traverse the list till the second element. You will traverse the list till the second element, or in this case the third element, because we are starting from 0. So you will traverse the list till the third element and you will return the address of that list, of that node. You will traverse the list to the third element, in this case 0, 1, 2, and you will return the address of that node. So it will traverse from here to here to here, and it will return this address of the node. That will become my index. So at the back end, it is still this long process. Though for a programmer, it is easy. Now we have an index for linked list. Yeah, this is so simple. But at the back end, still these all processes are happening. If we have thousands of elements, if we want to access 998 index, so it will traverse 998 nodes. It will, and it will provide you the index. It is easy for you, but for the computer, it is still traversing 998 nodes. Fine. So this is how index are given in linked list. So I hope you understood how the indexes are given in linked list. So we can use, for a programmer, it is very easy. Just remove the element at index 3. So yes, linked list is working, but still at the backend, this whole process is happening. Okay, array list provides us with index, so backend this all process does not happen, but for linked list every process happens. Fine. So let's get the size now. System.out size of our linked list. Size of our linked list is simply linked list. This is the method that is from the collection. As if you remember, this is for the method that is collection interface. Okay, the size method. So ll object dot size. Fine. If I run it, it simply will return me the size of the object. Sorry, it will return me the size of the linked list. Okay, so the size of the linked list currently 4. We started with 5, we deleted d, and now it is 4. So next what we will see add an object at a particular index. Add an object at a particular index. So how you will get the index? The whole process. So before printing, let's just add. So ll.object dot add, and I want to add at index 3. I have deleted from index 3, and I want to add, for example, z. So I will add simply z, and now I will print my ll object. Fine. So when I print it, I will simply here get the list. Okay, so ABC at the index 3, it will print z. So how it inserted, that is same as we have learned in the linked list. Okay, it insertion is exactly same. Okay, how you insert at the middle. So how you insert, you will create a new node, you will change the address to here, you will change the address to here. It is same, no issues. Okay, as you have inserted in a W linked list before, but this everything is happening now in the backend. You do not have to write the code for it. It is already written, and you have to just call a method. It is that simple. Okay, the collections make things simple, not difficult. Okay, the next we have to do, we have to remove, but we do not know the index. What we will do now? We do not know the index. We want to remove C, but we do not know the index of C. So how you will remove it? So first let's find the index of C, and then let's remove it. So ll object, we want to remove an element C. We do not know, we simply do not know the index of C. So how you will remove it? Just get the index of C. How you will get the index of C? It's very simple. Use the index of method. So ll object dot index of, and I will simply use C. Fine. Now s out ll object. So what this will return me, index of, will return me the index of C. So that is 0, 1, and 2. That is the second node, and it will remove, the remove method will remove the second node. Okay. Now when I print it, the C will be removed. So two methods are used in a single line. Fine. That is not an issue. That is just another example. Okay. Now let's use the get method. As you can see, the C is removed. Now let's use the get method. So what get method will simply give me, so s out ll object dot get the element at index 4. So I will put the index 4, the element at index 4, 0, 1, 2, 3. I have nothing, so let me just reduce it to 3, because the size is now just 4. So the ll object dot get 3, I will get my answer as E. As you can see. Okay, so we have used so many methods. Now let's use some methods that are specific. I have told you there are some methods that are specific to linked list. Now let's use these methods that are specific to linked list. Okay, so ll object dot add first the character. So if I want to add D, or if I want to add G first, so I have added it first. So ll object dot add at last, add last, so h for example. So at last I have added add. Okay, if we want to get the first element or get the last element, we can also do that. First let's just print this much. So ss.l object, and the first element now becomes g and the last elements now become h. So insertion at the beginning and the insertion at the end. Now we don't have to write the code, we don't have to take care of those pointers. It is very simple, just add first and add last. These two methods will take care of everything at backend, okay, for us. As you can see, g and h are added. The next we can also have character c equals to ll object dot get first. If you want to get the first element, you can do like this, characters d equal to ll object, that is a reference variable, dot get last. Okay, so we have c and d now, so you can simply print c and d. Okay, when I print it, I will simply here get g and h. Fine, it will not delete those elements from the list, it will simply give me those elements. Fine. Now if I want to remove these first two elements g and h, what I simply have to do, we have a remove function, ll object dot remove first. Okay, as you can see, we have a remove function, remove last and remove first. So ll object dot remove first. Okay, so it is remove last, remove first. Now if I print, these two will again be removed. It's very simple. So this is how simple linked list, array list becomes while we use collections. Okay, yes, the performance on the computer is more, the performance criteria, yes, the computer at backend has to do so much work, but for programmers it becomes so easy. You can easily use these functions, dot add, dot remove, dot get index of, dot get, okay, dot get the last element, get the first element. It becomes so easy. We do not have to implement any of these functions. All these functions are already implemented in the linked list class. We have to just call the linked list class, create its reference variable, using this reference variable use all the functions that are implemented. This is so simple, right? So we have seen the array list, we have seen the linked list. Next we will see what are differences between array list and linked list, where we should use array list, where we should use linked list. Okay, and then we will see vector and stack. That will complete our list interface. Okay, so this is the difference between array list and linked list. Array list is the best choice if our frequent operation is retrieval, because random access is available as the last point has written because of the indexes. If our frequent operation is retrieval, then we will use array list because retrieval is fast. In linked list, retrieval is slow. Why it is slow? I have explained that though indexes are provided by a collection in linked list, but it is not direct indexes, they are indirect indexes. At the back end, it will traverse to that point and then it will return. Okay, no traversing needed in array list. In the worst case, array list worst case is when insertion on deletion. Okay, I have told you if you want to insert it, you have to create actually a new array list. You have to copy all those elements, so you have to copy thousands of elements if you want to add 1001 element. Okay, so insertion and deletion is still not good. It is a worst choice for array list if you want to do insertion and deletion. The best choice in this case is nothing but linked list. The best choice in this case is nothing but linked list. If the frequent operation is insertion and deletion, the best choice is linked list because you have to just add nodes. Fine, nothing else. The worst choice of linked list is retrieval operation. As I have told you, you have to traverse the whole list for retrieval operation. Okay, so if the frequent operation is retrieval, the worst choice is linked list and the best choice is array. So these 2 points should be clear by now. The underlying data structure here is the array list. Okay, sorry, the underlying data structure for the array list is resizable or growable array, and here it is W linked list. Random access is possible in array list, random access is not possible in linked list. So this was a few differences of array list and linked list if someone's asked you. So the next what we will see vector and stack. Now we are done with collection interface. We have seen what is list interface. We have seen the classes in collection interface. We have seen the methods in collection interface. We have seen the methods in list interface. We have seen the implementation class array list. We have seen the implementation class linked list. Now we will see what is vector and what is stack. Okay, so what is vector? Vector is a legacy class. What do you mean by a legacy class? Array list and linked list, these were introduced in 1.2 version of Java with our collection framework, but vector was already present in 1.0 version. Okay, it was configured to be present in collection framework when collection framework was introduced in 1.2 version, but it was already present in 1.0 version. So array list is the modified version of vector. The only difference is that a vector is serializable and array list is not serializable. So this is in the concept of threading. So when we will learn multi-threading, we will see what is serializable and what is not serializable. So this is the only difference if someone asks. So if you have a method of dot add in array list, in vector we had add element. If you have a method of add all in array list. So in vector we have add all element, remove element. So these were the only differences. Fine. So this is the most important difference, that vector is serializable and array list is not serializable, and we will learn about serializability in multi-threading. Okay, so now we will see stack. So stack is a subclass of vector, and we will see the methods in stack, and we will see some coding in stack as well. So till now we have seen collection interface, list interface, the implementation class array list, linked list, vectors, just a small vectors, and now we will see stack. So stack is a child class of vector. So before moving forward, let's revise what is a stack. Okay, so we have a stack. So this is how I think you know what is a stack. So this is how a stack is shown. Fine. We have majorly two operations, that is push and pop. Correct. We have pushed some elements on the stacks and we pop some elements from the stack. Okay, and what it is, if we push an element, it will be stored at the top of the stack. Since there are no elements currently, the top of the stack is bottom. Fine. If I push 1, so it will be stored here, and the top of the stack will now increase, +1. Now if I push 2, the top of the it will be on the top of the stack, and top of the stack will now point here. Okay, now if I push 3, it will be stored in top of the stack and it will point to the next one. If I push 4, now it will be here. So the top of the stack is nothing but here. Fine. If I pop the elements, now it will also be popped from the top of the stack only. The top of the stack is now pointing to 4, so it will pop 4. The top of the stack will decrease now to 3. Then again it will pop. So I think you know this, what is the basis of stack. Correct? We have pushed, we have popped, we have top of the stack. Fine. Now let's move forward. We have stack is a child class of vector. It is specially designed for last in first out order. Last in first out order. So let's see here. The first 2, 3, 4. This was my insertion order, 1, 2, 3, and 4. But when I pop, the insertion order, the popping order is 4, 3, 2, and 1. The deletion order is 4, 3, 2, and 1. So this was 1, 2, 3, 4, the insertion order, and the deletion order is nothing but the reverse. That is, this was the last in, but this was the first out. This was in and this was out. So this was the last in, this was the first out. This was the first in and he is the last out. Correct? So this is last in first out order. Okay, so it is specially designed for last in first out order. Next is the constructor. The constructor in stack is simple, just a single constructor stack. It generates an empty stack. Okay, now there are some specific methods in stack. Since it is also a legacy class, so there are some methods which were defined, that is push, pop. One method is simply push to push an object into a stack, pop to remove an object from top of the stack. We have a method peek. What peek does is, if I have my top of the stack is currently here at 4, so what peek will do, it will return the top of the stack, but it will not delete. So okay, so it is not pop. Pop, what it does, it returns the top of the stack and deletes it. But what peek will do, peek will simply return me 4 and it will not delete. It will not delete the top of the stack. Fine. So this is peek. Then we have empty. So it is actually empty now in collection, but since it was before collection, it was introduced before collection, the naming conventions are a little different. So here it is simply empty to check whether the stack is empty or not. And then we have a search. This is one extra one. What search does, it determines whether an object exists in the stack or not. If the element is found, it returns the position of the element from the top of the stack. For example, if I search 1, correct? So 1 is currently here. If I start from 0, so it is 0, 1, 2, and 3. So from the top of the stack, it will tell me the position of 1. It will return me the position of 1 from the top of the stack. So this is what search is. Now let's code and see these methods one by one. Fine. So now let's begin. So stack, okay, s equals to, now we have to input it. So stack s equals to new stack, and this is just a simple constructor, just a single constructor of stack. Correct? Just a normal stack. Fine. So now what we will do, we will push s dot push. So what we will push? We will push an element, for example a. Correct? Then we will see s dot pop. Again, let's push 2 or 3 elements b. Fine. Then s dot push 1. Okay. So it is heterogeneous in nature, no issue. Then if I print the current stack, it will be simply system.out.println s. Okay. Now what we will see after push, we will see simply pop. So this is the simple insertion and deletion. The only difference is we have to insert at the top of the stack and we have to delete from the top of the stack. Nothing will happen from the bottom of the stack. As you can see, it is a, b, and 1. Next, what we will do, we will pop. So s dot pop, we will pop an element, simple. So we do not have to pass the index, so we do not have to pass anything, because it will always pop from the top of the stack only. Okay, so top of the stack is currently 1 because this was the last element that was inserted, so it will not simply pop 1. And let me print it also. So s out s. So now as we can see, we will see that 1 will be popped. Now my stack will simply be remained with a and b. Now a and b is remained. Okay, so we do not have to pass anything because it will always pop from the top of the stack. If we do seek, if we do peek, s dot peek, also it will peek the top of the stack only. Okay, nothing else, only the top of the stack. It will not delete it, it will only peek it. So when it peaks, the top of the stack is now b, so I returned my b. And now I can tell you that, see, it will not it is not deleted after peak. It will be deleted after pop, but it will not be deleted after peak, the top of the stack. We still have b in it. Okay, so this was push, pop, peak. So next we will see search. So s out, simple, s dot search. Let's search for b. So when I search for b, simple, it will return me the distance from the top of the stack. So b is at the bottom, a is at the top, so it returns me a 1. So let's add more element. So s dot push, let's push some more elements, c, and one more, s dot push, and let's push d. Okay, now let's see what our stack looks like. So system.out.println s, and when I run it, so my now top of the stack is d, then it will have c, then it will have b, and then it will have a. So a is at the bottom and d is at the top. Fine. Now copy this one again. Now we have to see what is location of b. Okay, it will search for b. Now let's see, when it searches for b, top of the stack is now d, what will be my answer? Okay, so my answer is 3. So from the top I am the third element. From the top I am the third element, that is b is the third element. Now if I search for something that is not inside the stack, it should return me -1. So z is not inside the stack, so now it should simply return me a -1. So these were push, pop, peek, search, the methods that are present inside stack class. So this was stack. So now we have completed with our list. So in our list we have seen many things. We have seen the methods in list interface, we have seen the methods of collection interface, we have seen the array list implementation class, we have seen the linked list implementation class, we have seen vectors, and we have seen stack. Okay, now we will move on to the second one. After list we have set. So now in the next video we will move on to set. Okay, thank you.